This is how I explained it in my last class, and it seemed to really help. So stick with me. I am going to talk Twilight here because that was the only love triangle I could think of. So, I know, right? It's great. So right now, this over here is Bella and Edward together. Bella plus Edward. Edward is NO2, and NO. So this right here is Edward.
I'm not a werewolf.
And this is Bella. But in the second book, when Edward goes away, Bella's like, oh, I'm going to go hang out with Jacob. So this is Bella. And then Bella and Jacob together make ozone, right? So there you go. Synopsis of the second book. But in the third book, we realize that Bella and Jacob are not meant to be. And so Bella goes with Edward. But for a second in the second book, it really was like back and forth. You're like, is Bella going to be with Jacob? Is Bella going to be with Edward? We don't really know. So that's kind of what the reaction is happening right here. That Bella can either be with Edward or Bella can either be with Jacob. And she kind of oscillates back and forth trying to make her decision, right? Then, here comes the third book. Ready? So, in the third book, Bella and Edward get married, right? So they're pretty much an item. So poor Jacob's over here by himself. And then he gets super creepy, and he falls in love with Renesmee.
No.
And then they become an item.
She's the baby.
Renesmee's the baby of Bella and Edward. It gets real weird. Okay, but if you look at this. By the time we get to the third book, is Bella going to be leaving Edward at all? No, they're going to be stuck together. Are Jacob and Renesmee not going to be together? No, they're going to be together. So they are stuck together. And so now we have a permanent outcome. Or in this example, we have photochemical smog. So let's go through this in actual science, okay? So in actual science, when we look at the reaction of NOx and ozone being created, NOx can turn into ozone, ozone can turn back into NOx. So without anything else playing in this reaction, we're not going to have any ozone accumulating because ozone breaks back down and it turns back into NOx, which is great because ground level ozone is something we do not like. If you're currently drawing on your paper, please stop. I need all eyeballs up here. If you're drawing on your black paper, please stop. This is a really hard topic, and I can guarantee this will be on your test. So it would be worth your while to listen to my melodious voice. So this goes back and forth, no problem. As long as the sunlight's out, the sunlight will break down NOx, sunlight will also break down ozone, and they will switch back and forth, neither one accumulating more than the other because as soon as they're built up, they break down again. However, when you add Vox into the situation, ozone right here cannot break down and recombine with NOx because NOx is combined with Vox and there's no way to go back. So basically we tie up the rebound and so there's no one to rebound to if we want to talk relationship status. Okay? So at your table, you're welcome to use the Bella Edward Jacob situation. You're welcome to use the more scientific words if you want to. I want you to describe photochemical smog and how it is created with your table. Ready, set, go. Bella's the oxygen.
Bella's the oxygen. And she can go to NOx, and the other guy was his name. And another oxygen, right? And so,
Are they both?
so then,
Wait, hold up. Are they both NO2?
No, so Jacob is O2, Edward is NO.
Oh,
she's going back and forth. But then Renesmee comes in, block. And so So Jacob gets caught. And then so Bella can't go back to Jacob, so she's stuck with Edward. And then it's Smog.
Okay, so we say oxygen, and so she's happy with, she can be happy with either one, right? Back and forth. Yeah, okay, so she can bounce back and forth, but then, when he becomes tied up with her daughter, then there's no one there to rebound back at, so she chooses Ed, but she chooses, but anyway, when she's bumped up, there's no one to go back to.
All right, take about 30 more seconds to explain it, and then we're gonna have somebody explain it to everybody.
Yes. The marriage votes. That's it. Okay, your response.
Okay, here we go. So the person who's going to be explaining this to us is going to be Sarah. Okay, do your best. I'll fill in anything that you miss. Okay, everyone listen.
Just like the whole thing?
Yeah.
Okay, so nitrogen,
Mm-hmm.
NOx,
Yep.
gets like broken up, and then the extra oxygen goes in the exposure.
Perfect.
But those can like interchange, but if there's like the Vox, then the oxygen goes and makes ozone, and the nitrogen goes with the Vox, and then those go together,
Mm-hmm.
and then it's like stuck.
Perfect. It makes photochemical smog and it's stuck. So the big thing here is that without Vox, this reaction would not be that big of a deal because we could go back and forth. So now that we've gone over that, let's talk about the effects of photochemical smog. So, first of all, look at Utah. Wah, wah. Literally the worst. Right here, look. That is the darkest you can get, guys. So, great for us. It can give us permanent lung tissue damage after long exposures, respiratory problems and aggravating existing respiratory problems, eye irritation, decreased visibility, and damage to plants and ecosystems. So do me a favor. Usually when we talk about photochemical smog, we talk about how it affects humans. It says right here that it can damage plants and ecosystems. So take 30 seconds, talk with people at your tables, and figure out how it can be damaging to plants and ecosystems. Ready? Turn and talk.
Probably disrupts, like, because air quality is like the plants use that, like the plants need air, they need, like, most of the like trees and to make that we are around it. That's what I don't know, like, a good something from enrichment when it comes to like ruined air. Yeah, so it's not like it's normal. Yeah, like, it's not what nature had it. Maybe the polluted air also like.
All right, bring it back together in 3, 2, 1. This question is going to go to Jonah. So, how does photochemical smog affect plants and ecosystems? Okay, cool. We're going to keep it on the line. All right, now we're going to bounce it over to Sadie. What do you think?
Maybe it can just like it says respiratory problems, like maybe it can like affect the animals that are in the ecosystem, and then like if there's no animals regulating like plants, then they'll get overgrown.
Yeah, absolutely. So we could see like a cascading effect, right? If we affect the animals, they can't breathe as well. That's definitely going to cause a problem. Okay, Jonah, coming back to you. I'm going to give you a little bit of an idea. Let's see if we can run with it. If we don't have quite as much sunlight because it's smoggy, how is that going to affect plants? Yeah, they're not going to be able to go through photosynthesis, right? Which means we're not going to be able to produce oxygen, which animals need. We're going to accumulate more smog, and so it's going to cause a lot of problems. So we're going to skip this video because it's 8 minutes and also not that important. Actually, I'm going to scoot backwards. Haha, that's what I want. So this is the actual words to go with everything that we did this morning to kind of help you understand it. So during peak traffic hours, nitrogen oxide, so something to be aware of, NO is not the thing that goes through the chemical reaction. NO2 is created later. So during peak traffic hours, NO and hydrocarbons are emitted along with carbon monoxide as car exhaust. So step one to creating photochemical smog is we have to get cars on the road and their exhaust needs to start to accumulate. Without the accumulation of car exhaust, there is no way that we would have photochemical smog. So as we get the NO from the cars, it is slowly oxidized into NO2. So we start to grab more oxygens from the atmosphere and create NO2. And as soon as we start having NO2, we're going to start creating ozone. We're going to start having that teeter-tottering effect back and forth, creating ozone, creating NO2, creating ozone, creating NO2. But in the presence of sunlight, NOx reacts with VOx to create ozone and PANs. So ozone or pause. What is PANs again? Photochemical oxidants. So just photochemical pollutants are PANs. So in the presence of sunlight, NOx and VOx come together to create the photochemical smog. And the big idea is that photochemical smog is a problem in urban areas because of the large number of motor vehicles there. So just out of curiosity, who here actually carpools to school? Raise your hand if you carpool to school. So we have 1, 2, 3, 4, 5 people that carpool to school. Raise your hand if you don't carpool to school. Raise your hand high. So the majority of our class does not carpool to school, even though you probably live fairly close to somebody else who goes to Skyridge because this is a community public school. So we are putting a large amount of motor vehicles on the road every single day. And so this causes a big problem. So my question to think about at your tables is, at what time of the day, bless you, do you think photochemical smog is the worst? So at your tables, start thinking. So I'm going to give you some options. So I'm going to say 8 a.m., 10 a.m., 12 p.m., 2 p.m., or 4 p.m.
Wait, dear, what is like Vox?
Vox, it's anything that has a smell. So any organic material that has a smell is a Vox. So like gasoline, the smell of gasoline is a Vox. The smell of pine trees is a Vox. The smell of paint or carpets are Voxes.
Basically, it like reacts with like everything.
Mm-hmm. Yep. Okay, let's think about your answer and we're going to vote. We're going to take a class vote. Okay. Who thinks that photochemical smog is the worst at 8 o'clock in the morning? Raise your hand. Any votes? Okay, we have no votes for 8 a.m. Okay, who thinks 10 a.m. is where it's the worst? Raise your hands high. Be brave. 1, 2, 3. So we have 3 votes for 10 a.m. Who thinks noon, 12 p.m. is going to be the worst? 1, 2, 3, 4. 4 votes. Who thinks 2 p.m. is going to be the worst? So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, who thinks 10 and 4 p.m. is going to be the worst? Raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So the answer to this is actually a grouping. It's this time frame right here. So the reason behind this is because at 8 a.m., has the sun been out for a long time? No. Has there been a lot of cars on the road yet? No, like we're starting to get the rush hour traffic. Usually most businesses start at 9 o'clock in the morning. Unless you're a teacher, then you're here at the butt crack of dawn. So at 10 a.m., how much sun do we actually have?
A little bit.
A little bit, right? The sun's coming out, it's rising, which is awesome, which means that we're probably going to get some sort of chemical reaction, but not a lot. How about 12 p.m.? How much sun do we have?
A lot of sun.
A lot of sun, but the cars aren't on the road. But the problem with this one is that the sun's here. We have all of the stuff in the atmosphere, but we haven't had time to accumulate it. So we have the sun out, the chemical reactions are starting, but we haven't accumulated all that pollution yet. So between 2 and 4, we're going to have ample sun. We're going to have lots of time to create it. And so that's when our smog is going to be the worst. As soon as the sun goes down, it kind of resets itself a little bit, and then the chemical reaction happens all over again. So that's the idea behind photochemical smog. So how do we reduce photochemical smog? What's the big takeaway of this? Number one thing we can do to reduce it is drive less. Walk, bike, carpool, use public transportation whenever possible. So whatever you can do to reduce the amount of emissions that you're creating is going to be super helpful. Another thing you can do that's not on here is called trip chunking. It's whenever you go out, like whenever you're in the car, do every single errand that you have to do at one time and then go home. Don't go home and then go back and then come home and then go back and then come home and then go back. Like for example, when I go home from the day, I go pick up my kiddos. Then if we need to go grocery shopping, we'll go grocery shopping. If I need to get gas, then I'll go get gas and then I'll go home. So I do all of my traveling in between the time that I leave school and I go home. As soon as I get home, I'm home for the night. And then that's trip chunking. Another thing is maintain vehicles to reduce emissions. So we played around with this last time, right? We grabbed emissions from people's cars. We saw that some emissions were worse than other emissions. So making sure that when you take your cars in for safety and emissions, even though we don't do safety anymore, when you registration and emissions, make sure that you actually are doing that, because the more tight we can be on emissions, the less pollutants are going to actually get into the atmosphere. Refuel during the cooler hours of the day. This one's kind of a weird idea, but during the warmer parts of the day, we produce more VOCs from gasoline. So if we produce less VOCs, we're going to have less photochemical smog reactions happening. Avoid products that release high levels of VOCs, and then avoid gas-powered lawn equipment. So like lawn mowers, leaf blowers, try to find electric ones. Electric's not always the best because you're still using energy, and that energy could come from coal, it could be coming from petroleum, it could be coming from any sort of thing, but it's not producing NOx, and NOx is what goes into photochemical smog. So if we're focusing just on photochemical smog, using electric lawn mowers, leaf blowers, weed whackers are going to be helpful in that situation. Yeah, Sadie.
So like in Utah, we always have like a lot of smog, but why is it like we don't get a lot of smog like in the summertime? It's kind of like in the spring and in the fall, I feel like.
Man, I could not have asked you to give me a better segue into thermal inversions in the wintertime. Oh my gosh, this is like perfect. So to answer that, it's because in the wintertime, we get things called thermal inversions. So to kind of tell you how this works, if you look at how our air usually is, we usually have warmer air closer to us and colder air up in higher elevations. And because of this, warm air rises, which means that this air is going to go up and it's going to start mixing with the colder air up there, and cold air sinks down. So we have this circulation of air. So in the summertime when we have this, it helps bring some of the pollution that's closer to us up and away from us, meaning that we're not going to be inundated with quite as much smog. However, in the wintertime, we go through something called a thermal inversion. So if you look right here on the very bottom of our graphic, in the wintertime, we have cool air closer to us. So this could be for a couple of reasons. I mean, number one, if you look out the window right now, it's snowing. Snow is going to keep the ground level area really, really cold. And what does cold air do? Cold air? Sinks, yeah. Cold air sinks, right? So all of the pollution that we're creating, all the photochemical smog that we're creating is going to be sinking close to us. It's not going to be rising. It's not going to be going into other layers of the atmosphere. Then we have a layer of hot air up here and a layer of cold air. So this air up here is circulating and doing what it's supposed to, but because of the thermal inversion, we are keeping all these pollutants so close to us. So this right here, this picture up here, is actually a picture of the Draper Valley, so the Salt Lake Valley. I grew up right around here in Sandy. So look how disgusting that is, guys. So if you had to guess, what temperature do you think this air is up here?
Warm.
It's warm. What temperature do you think the air is down here? Cold, yeah. So the cold air is being stuck down here and the warm air is rising. So what I want you to do is at your tables, you have these things called density bottles. Go ahead and give them a good shake. Watch what happens. And then at your tables, use this to describe how a temperature inversion works. You okay there? What happened? Oh my gosh. Okay, so let's have somebody share out what they talked about at their table with their density bottles. So this one is going to go to Madison Johnson. So what did you guys talk about at your table with your density bottle?
So we talked about how the white beads kind of acted as did we say warm air or the top? Yeah. So we talked about how the water on either side kind of represents the cold air, and then the beads, some of the beads represent the warm air, and it shows that like you would trap them both together. I'm not explaining it very
No, you're doing good. You're doing good.
About it.
No, you're doing so good. Okay, so you're totally right that the layers on top and the bottom of the beads are going to be our cold air. So this in the middle is going to be our pollution, and this layer of white beads is going to be the warm air. So the warm air is trapping the cold air underneath, and the colored beads are your pollution. And so the pollution is being trapped, and no matter what happens, as long as that warm air and that cold air are sitting on top of our pocket of cold air, all of this pollution is going to be stuck super close to us. Good answer. So to kind of go through this and give you guys an idea, we're going to watch this video. It's really short, and it actually talks about Utah in particular.
Before you can understand Utah's air quality challenges, you need to understand a little bit about our geography. Many of our valleys are surrounded by mountains. Take the Salt Lake Valley as an example. It has the Ochre Mountain Range to the west and the Wasatch Mountain Range to the east. These mountains meet at the south end of the valley to create a bowl. During the winter, this bowl causes a weather event known as an inversion. Basically, a layer of warmer air acts as a lid, trapping the cooler air below. And just as the cold air can't escape, neither can the pollution. We can't control the inversion. While it happens just a few times each year, the pollution it traps can't leave the valley until after a storm or heavy winds blow through. What we can control are the emissions we release into the air. This becomes increasingly important as the amount of pollution in our air doubles every day during periods of inversion. But the good news is, even simple changes to your daily routine can have a big impact on our air. Things like reducing the temperature on your thermostat, being idle-free in your car, or carpooling and riding transit help every Utahn breathe easier. In other words, if we work together, we can reduce the negative effects of inversion and improve Utah's air quality. So show you care about Utah's air and make changes to reduce your emissions by visiting youcare.org.
Oh, we totally will. So let's answer these questions as soon as it comes up. There we go. What phenomenon causes an inversion? So this question is going to go to Emma Ball. So, or what conditions, I guess. Maybe not phenomenon, but like what conditions?
Like the air, I guess, so that cold air in the bottom gets trapped, because the warmer gets trapped as well. I guess I explained it really
No, but I totally understand what you're saying. So you're saying because of the mountains right here, right? The colder air gets trapped underneath and the warm air kind of comes a lid, right? So going along with that, what phenomena can end an inversion? So this question is going to go to Isaac or Jamal. So what thing can stop an inversion?
Like, not doing the mission.
So like what natural thing? If you are having a hard time thinking of it, look out the window.
A storm.
A storm. A storm or wind coming in is what can end an inversion. So usually when we have really crappy air, we're like praying for rain or snow to come in and clean it out. What happens to the air pollution every day during an inversion? This question is going to Gracie Ball. It doubles. So the air pollution doubles every single day in inversion. And so that's something to be aware of because our air quality can get really, really bad really, really quickly. So before we move on to acid rain, let's do fist to 5. 5 meaning I understand photochemical smog and I understand inversion pretty well. If you were to ask me a question about them, I could have a decent conversation telling you about it. 4 means I'm feeling pretty okay. I probably could tell my parents about it because they don't know much about it and so I'd sound really smart. 3 means, okay, I'm kind of in a really gray area. I understand the basics of it, but there's still some things I don't understand. 2 means, D-Heart, please probably request me for sky time. And a 1 means like, you really need to request me for sky time. So show me where we're feeling. Okay, cool. So we're going to circle back around to this, and we'll make sure that we hit it again before we leave today. So now we're going to talk about acid rain.
What is acid rain? Acid rain is any form of precipitation with high levels of nitric and sulfuric acids. It can occur in the form of snow,
Okay.
fog,
Pause.
even dry
Stop it. So, something to be aware of. In environmental science, we don't usually call it acid rain. We usually call it acid deposition because how many different forms can it occur in?
3.
Like 3 or 4, right? So we have snow, fog, dry materials, and rain, right? So it can come down in a couple of different ways.
materials that settle to Earth. Most acid rain is caused by human activities. When people burn fossil fuels, sulfur dioxide and nitrogen oxides are released into the atmosphere. These gases react with water, oxygen, and other substances to form sulfuric and nitric acid. Winds may spread these acidic solutions over hundreds of miles. After it falls to Earth, acid rain enters water systems as runoff and sinks into the ground. This can make water toxic to crayfish, clams, fish, and other aquatic animals. The rest of the food chain, including non-aquatic species such as birds, is often affected as well.
Somebody remind me, what is it called when we take something and it hurts other animals further up the food chain? Close, not accumulation. Magnification. Biomagnification, yep. So this can biomagnify through the food web.
Acid rain also harms forests by damaging trees' leaves, robbing the soil of essential nutrients, and making it hard for trees to take up water. By designing cleaner power plants and using fewer fossil fuels, we can reduce the number of pollutants that create acid rain.
All right, so that's kind of fun because, well, I guess fun is not the right word to describe acid rain, but it talked about the energy that we had talked about last unit, right? About the renewable energy and how those don't create pollutants, which can really help us not have acid rain. So let's go to these questions. What are the forms of acid rain? So we said there were about 4 of them. This question is going to go to Daisha.
Snow, rain, fog.
Yep, snow, rain, fog, and even there's like solid particles that can come down. How do human actions contribute to acid rain? This question is going to Noah. What human conditions contribute to acid rain?
Pollution.
Pollution, yep. Any kind of pollution, mostly from burning coal and burning diesel fuel. Next, what are the ingredients for acid rain? This question is going to Eliza. Perfect. So nitrogen oxide and sulfur come into the atmosphere and they mix with water and oxygen. Yep. So those two pollutants mixed with water and oxygen create that. Yep. NOx and sulfur dioxide are the two things that go into the atmosphere and work with oxygen and water, humidity. What are the effects of acid rain? This question is going to go, not here, to Brooklyn. What are the effects of acid rain?
It can drain like the nutrients from soil. It can get into the water and like be bad for the marine animals, and then the birds who also are eating the fish get
Absolutely. So it washes all the nutrients out of the soil. It affects trees' ability to take up water. It can affect their leaves, and it also has a really big effect on aquatic ecosystems, making it hard for them to reproduce and also making it hard for them to survive, and it can biomagnify through the food web. Last one, how can acid rain be mitigated or stopped? So this question is going to go to Jessica.